Hello students, let's try to understand order of reaction student. I have taken this from the book student. What is the modern ABC book student? Okay. So student, we have to understand what do mean by order of reaction, right? So here definition is there. Sum of the power to which the concentration terms are raised in the rate law equation to express the observed rate of the reaction. So this is what is called student order of reaction. So sum of power of concentration over the reactant is called order of reaction. Now see, this is the rate expression student, and here power is there, P, Q and R. So order is equal to, see the order of reaction N is equal to P plus Q plus R. So this is how the order of reaction is expressed student. What is the need of the order of reaction? The dependence of the reaction rate on the concentration may be expressed in term of order of reaction. So concentration terms can be expressed in the term of order of reaction. To calculate the order of reaction, we must carry out the experiments to find out the dependence of the reaction rate on the concentration of each individual reactants at a given temperature. Moreover, the concentration dependence of the various reactant, as we have seen, is given by the rate law. Thus the order of reaction is defined as the sum of power of concentration of reactant student. Now PQR, the order of the order with respect to individual reactant, and overall order of the reaction is the sum of these exponent, that is P plus Q plus R. When N is 1, the reaction is said to be first order, N is 2, the reaction is said to be second order, and so on. So we are going for the example students, some example for the reaction of different order. So reaction of the first order. What is the first order? Decomposition of nitrogen pentoxide. So N2O5 is decomposing to give 2NO2 plus half O2 student. This is the first order reaction, right? Now let us move on the second one student for the first order reaction. Here is decomposition of ammonium nitrite NH4NO2 student. It is giving N2 plus 2H2. This is also the first order reaction. Here is rate is depending on the ammonium nitrite. Decomposition of H2O2 in presence of I minus. So H2O2 is there student. I minus, it is giving H2O plus half O2. So rate is what student? KH2O2. So this is the first order. Decomposition of SOCl2. This is also going to be first order. Here you can see rate is depending on the only one molecule. Next one, reaction second order we are going. Example of second order. So 2NO2, it is giving 2NO plus O2. Here power is C student. In this case, how much power is there? 2. So order will be how much student? Order also will be 2. Here is reaction between H2 and I2 to give HI. So what is order will be student? Here is H2 power 1 and I2 power 1. So 1 plus 1, how much is will be there student? This is second. Now reaction between NO and O3, this is also going to be the second order student. Okay, here is 1 and here is 1, so 1 plus 1 2. Now third one, reaction of the third order student. We are going to understand third order. Reaction between nitric oxide and oxygen. It is, so what is the rate student? You are expressing K, rate is equal to K, NO power 2 and O2. So here is 2 plus 1, it is going to be third order. Reaction between nitric oxide and Cl2, it is also going to be third order. Reaction is also possible in fractional order student. Here in this reaction, decomposition of acetaldehyde is a fractional order reaction. CH3CHO, it is going to give CHO plus CO. So here is rate is C, expression 3 by 2 is there. So order is 3 by 2, 1.5. H2 plus Br2 student, 2HBr. Here is also it is the half order reaction student. 1 plus half. 1 plus half means it is going to be 1, right? 1 by 2 means 1.5 student. COCl2, it is also 1.5. Zero order reaction. Now a reaction of zero order reaction are known in which the rate of the reaction is independent of the concentration of reactant. For example, decomposition of ammonia at the surface of metal like gold, platinum, etc. are zero order reactions. So 2NH3 it is decomposing to give N2 plus 3H2. It has been observed that the rate of the reaction is independent of the concentration of ammonia. So it is the zero order reaction. In this reaction, the metal acts as a catalyst at sufficient high pressure of ammonia. The surface of the metal is completely covered with the reactant molecule. As a result, increase in the pressure, concentration does not have any effect on the amount of reactant at the surface. Therefore, the rate of the reaction does not depend upon the concentration and the order is zero order reaction. Similarly, thermal decomposition of HI on the gold surface is also zero order reaction. These are the order of reaction. Now we have to understand unit of the order of reaction that we will do in the next video, student. Thank you.